So power reduction formulas are related to the cosine double angle. So let's take a look at that. So cosine double angle is equal to, at first glance, cosine squared of x minus sine squared of x. Applying the Pythagorean identity here, we can rewrite that as either cosine of 2x is equal to 2 cosine squared of x minus 1, or 1 minus 2 sine squared of x. And if we solve this for the cosine, that gives us the half angle formula. If we solve this one for the sine, that gives the half angle formula for the sine. Now, if we solve this for the cosine squared and sine squared without doing the square roots, those are what they call the power reducing formulas. So for example, since this one has a cosine to the 4th power, I'm going to look at this one right here. So I'm going to add the 1 to the other side. So that's going to give me 1 plus the cosine 2x. And then divide by 2. So now I have cosine squared of x, and this is what they call a power reducing formula for cosine. It takes the square of a cosine and knocks it down to a single power. Right now we have it as a trade-off. Instead of a square with an x, we now have a 2x with a fraction outside. Right, so there's trade-offs there, but that's the power reducing formula. There's a similar one for sine. So to do this here, I'm going to think about this as the cosine squared of 2x squared, right? So the 4th power is the square of a square. So first I'm just going to do that part right there and then square the result because I need to get rid of all the exponents. So we can only get rid of a square at a time. So that's no problem. I know based on that formula, the cosine squared of, oh yeah, and there's already a 2x in there. So if there's a 2x here, this would be a 4x over there. So keep that in mind. So another way to think about this formula is, let's call this theta instead, different color maybe. Theta, theta. Whatever angle is here in this under the square of the cosine has to be doubled on the other side. So whatever angle I have over here has to be doubled on the other side. So that's going to be equal to 1 plus cosine of double that angle. So that's going to be a 4x over 2. Now we want the square of that. So now we just square both sides. So that's what I have at the moment. So let's do that. So squaring the numerator means I'm going to have a 1 plus cosine of 4x. Square means multiply by itself times the cosine of 4x over the denominator squared, which is now a 4. Distributing across the numerator, we're going to get a 1. And then we're going to get a 1 times cosine of 4x. But here we're also going to get a 1 times cosine of 4x. So that means we're going to have 2 of those cosine of 4x's. And then finally cosine of 4x times cosine of 4x, which is the cosine squared 4x. That is all over 4. So we considered the cosine to the 4th as the cosine squared squared. Cosine squared, we applied the angle reduction formula, but then we had to square the whole thing. So now we know that the cosine squared of 2x, cosine to the 4th of 2x is equal to that right there. Oh, Emily must be having some internet trouble. Welcome back, Emily. We have 2 Emilys. Okay, so we're not quite done because it said without exponents, and I have an exponent right here. So I need to rewrite that one. So let's pull that off with a different color. So we want to know what is the cosine squared of 4x. And so we're applying this formula again and again. It says take whatever angle is within the square of the cosine and then double it on the other side. So 1 plus cosine of twice that angle, which is going to give us an 8x all over 2. So that's going to go in here. Now, sometimes instead of over 2, I like to actually carry out that division. And I'm going to do that here because it's going to make it easier to finish. So this would be 1 over 2 or 1/2 plus cosine over 2 would just be 1/2 cosine. So this right here, I need to fill in here in just a second. But I'm going to do the same thing with this 4 out front. I'm going to write it as 1 over 4, right? 1/4 plus this would be 2 over 4, 1/2 cosine of 4x. And then that's over here too. So I'm going to have a plus 1/4 that thing. And we just determined that that thing right there is this thing right here. So in the parentheses, I got a 1/2 plus 1/2 cosine of 8x. So let's finish this by distributing the 1/4. So 1/4 plus 1/2 cosine of 4x. Oops. Plus 1/4 times 1/2 is 1/8. 1/4 times 1/2 is 1/8. And then I have like terms here and here only. This is a 4x, that's an 8x, so those aren't like terms. So finally, I've got 1/4 plus 1/8. Let's see, 1/4 is 2/8, so that would be 3/8 plus 1/2 cosine of 4x. We dealt with that 1/8 plus the other 1/8 cosine of 8x. And there was plenty of opportunity for me to mess that up. So I really need to graph this thing right here, which has no powers, and compare it to the graph of the cosine of the 4th power of 2x to see if I got it right. Let's do that. So 3/8, 1/2, 1/8. See if I can remember that. Oops, wrong button. There we go. And let's clear this stuff. So we are going to take the original cosine raised to the 4th of 2x. And it does not like that notation, okay? Did I mistype there? All right, so we're just going to have to raise this whole thing to the power 4. Oops. Ooh, that's a cool looking wave. And we think that's the same as 3/8 plus, I believe it was 1/2 cosine of 4x plus 1/8, if I got that right, cosine of 8x. And it does look like my green wave sits on top of the blue wave. Yep, got it right. So in summary, we had to write the 4th power as cosine squared squared and deal with just the square first, applying the angle reduction formula, just like the half angle. Then we squared that result, so we would have the cosine to the 4th, and then we had to do a bunch of distributing, because whenever you square a binomial, you gotta multiply it out. We then dealt with the divide by 4, and then we had to get rid of all exponents, so we had to apply that reduction formula again over here, and then cleaned it all up. So that applied 2 iterations of the power reducing formula with a wee bit of algebra in the middle and at the end. And just careful accounting of our values.